Hi everyone, we're going to look at how to do recursive to explicit formulas for geometric sequences. Whenever you think geometric sequence, I want you to think exponential relationship or exponential function. Because it is just like how arithmetic sequences are like linear relationships, geometric sequences are like exponential relationships. So instead of a constant adding or subtracting like in arithmetic, geometric sequences have a constant factor, a constant amount we're multiplying by. So what we're given here is recursive relationships, and we're going to make them into explicit formulas. So whenever you think of a recursive relationship, think of it in terms of next and now. How do we take the current thing and get us to the next thing? So in this case, it'll be next equals now times something starting at something. That's what a recursive relationship looks like for a geometric sequence. So for the first one here, f of x would be the next is the current times -4, starting at 24. So we can use this to build a table. So for our table, we're going to use x's and f of x's, since that's what we're given in our relationship. We're going to skip 0 for now. The first term is 24. And then we would just multiply that by -4 to get the next term. So 2, 3, 4, etc. After that, all they would do is just multiply by -4. -4. So this would be -96, and we don't really need anything more than that. We could keep going here and get the next one. 3 would be 384, but we don't really need to keep going more beyond that. What we really need is what are we multiplying by and where is the y-intercept. The y-intercept would be something times -4 is 24. So working backwards, 24 divided by -4 would be -6. So that's our y-intercept. And we need the y-intercept because every exponential function is of the form y equals a times b to the x, where a is the y-intercept and b is the amount we're multiplying by, the factor. So in this case, it'll be y equals our y-intercept, -6, times -4 to the x. That would be one way to represent this situation. But because it's f of x, we're just going to tweak it a little bit. We're going to call it f of x equals our y-intercept times -4 to the x. Now, on the formula sheet for any exam, what you'll see is this formula instead. You'll see a of n equals a of 1 times r to the n minus 1. So that's the same relationship, just written a little bit differently. Instead of using the 0th term, the y-intercept, they're using the first term. So we could write it using that. We could say f of x instead, no big deal there, equals the first term, 24, to the -4 to the x minus 1. This is actually the exact same thing, because if you were to use exponent rules here, you could say f of x equals 24. So -4 to the x minus 1 would be the same thing as -4 to the x times -4 to the minus 1. And then if you do, rearrange the multiplication here, do 24 times -4 to the -1. That would be 24 times 1 over -4 times -4 to the x, and that would be -6 times -4 to the x. So that's why they're equivalent. So we don't really need this other form. If the first one makes sense to you, why would we use more than that, right? So this is all just kind of extra showing why the other formula works, but we don't really need it because the first one is all we need. It's correct, so why don't we just stick with what we're good at, like that, using the y-intercept and the rate, the factor here. We're going to multiply by -4, so that gives us our formula. For the next one, very similar, a little bit different notation. This is the next. This is the now times -3, and we're starting at -15. So we make our table, x and f of x. So our first term is -15. So our second term would be that times -3. Yep, times -3. There we go. So that would be positive 45. So something times -3 is -15. So using division, we can work backwards here to find the y-intercept, which would be 5. So then for our formula, f of x would be the y-intercept, 5 times our growth factor here, or our multiplication factor here of -3 to the x. A times b to the x format, and we're done. That's all you have to do to write an explicit formula. For the different notations down here, again, very similar. This is the next equals the now times 2, starting at -8. So for our little table, let's use different notation. Let's use n and a of n, since that's what we're given. Our first term is -8. Our second term would be that times 2, which would be -16. So working backwards, something times 2 was -8. That would be -4. So our formula is just the y-intercept times that factor of 2 to the n this time, since we're using n's instead of x's. Just make sure you don't mix up your letters. If you're using n's, make sure everything is in n's. You can't have x's and n's all in the same formula. It wouldn't make sense for this situation. And for the last one, again, very similar. This is the next equals the now times -7, starting at -70. So we have n, a of n. So our first term is -70. Our second term would be that times -7, which would be 490. So our 0 term would be something times -7 is -70, which can be +10. So our formula would be a of n is the y-intercept times the -7 to the n. And that's how we write these formulas, again, using what we're good at, y equals a times b to the x, where a is the y-intercept, and b is typically called the growth factor or the decay factor. In this case, let's just call it the factor that we're multiplying by. That's it.